Hello students. In the previous class, we discussed what is composting, what are the uses of compost, objective of composting and how the process begins. Now we'll understand what is mean by aerobic composting and anaerobic composting. So these are the two main processes which are acting. So first we'll understand what is aerobic composting. So as I told you, the meaning of aerobic is in the presence of oxygen. So it is a process in which under environmental conditions the facultative aerobic organisms, principal thermophilic bacteria, utilize considerable amount of oxygen in decomposing the organic matter to a fairly stable humus or compost. So that is called as aerobic composting. So let us understand this with a reaction. So whatever the organic matter or the present in the solid waste, so it contains except plastic, rubber and leather component, all other organic fractions of municipal solid waste, they can be considered to be composted. Okay, then these materials, they composed of proteins, amino acids, lipids, carbohydrates, cellulose, lignin and ash. So if these organic materials are subjected to aerobic microbial decomposition, the end product what we get, that is known as the humus material, and we commonly call it as a compost. So this equation, you can see all the whatever the parameters or organic fractions which are present in the municipal solid waste, in the presence of oxygen, they react, and a final product what we get, that is called as compost. So here we can observe, once the reaction is completed, there are formations of some new cells also. So new cells that are produced, they become a part of active biomass involved in the conversion of organic matter, and on the death of again that new cells, it is converted into compost. So this, along with this, carbon dioxide, water, ammonia, sulfur, plus the some amount of heat is also generated. So this takes place in aerobic composting. That we have to remember is, this is in presence of oxygen, how the reaction takes place. So all the aerobic composting processes are similar. They all incorporate the three basic steps. The first step is pre-processing of municipal solid waste. So pre-processing includes receiving of the waste, removal of the recoverable materials from the collected waste, then the size reduction, then the finally adjustment of waste properties, that is CN ratio. CN ratio is carbon nitrogen ratio, addition of moisture and nutrients, etc. So this is the first step which we have to follow in aerobic composting, that is pre-processing of municipal solid waste. So it includes first the collection or receiving of this solid waste, then removal of all the recoverable materials from it, then you have to reduce the size with the help of different equipments to reduce the size. By breaking the municipal solid waste, we can reduce the size. Then lastly, the adjustment of the waste properties, that is what is the CN ratio, then addition of moisture and nutrients if required, all that we have to manage. Then the second step is aerobic decomposition of organic fraction of municipal solid waste. So whatever material which is present in the municipal solid waste, organic material, that will undergo decomposition in the presence of oxygen. Then the final product what we get, I called it as, I told you that it is a compost. So the product preparation, whatever product we are getting, we have to prepare it because we are going to market it. So the last step is to the product preparation and marketing of final compost product. So these are the three basic steps which are incorporated in aerobic composting. Then let us understand what is anaerobic composting. So anaerobic means this takes place in the absence of oxygen. So anaerobic composting is the breakdown of organic matter by reduction in the absence of oxygen, leading to the production of methane, that is CH4, and CO2 is carbon dioxide. So here what happens, the organic matter which is undergoing decomposition in the absence of oxygen, that will break down, and the final product what we get, that is a production of methane and carbon dioxide. So this is anaerobic decomposition. So here a number of anaerobic organisms, they work together to bring about the conversion of organic portion of the waste to a stable end product. So the one group of organisms is responsible for hydrolyzing the organic polymers and the lipids to the basic structural building blocks such as the fatty acids, monosaccharides, amino acids, purines and pyridines, and the simple aromatics. So these are this happens in the first step, that is the hydrolysis. So hydrolysis is the first step in the anaerobic decomposition, and the second step is acidogenesis, and the third step is methanogenesis. So what happens in acidogenesis? So the second group of anaerobic bacteria that starts fermenting and they break down the product from the first step or the first group to a simple organic acids. So this step is called as acidogenesis, the most common of which in anaerobic digestion is acetic acid. So this second group of microorganisms described as non-methanogenic, or they are also called as acidogens or acid formers. So this is in the second stage. Then in the third step or third group of microorganisms, they convert the hydrogen and the acetic acid which is formed in the acid stage, that is acid former, to methane gas and carbon dioxide. That is the end product of anaerobic decomposition or anaerobic composting. So these are called as methanogenic, or they are also called as methanogens or methane formers. So this is seen in anaerobic composting. So this we can represent with the help of a reaction. So here you have to show three stages, that is hydrolysis, acidogenesis and methanogenesis. So the lipids, polysaccharides, protein, nucleic acids which are present in the municipal solid waste, they convert into fatty acids, monosaccharides, amino acids, purines and pyridines, and finally in the second stage they undergo acidogenesis, and the last product in the methanogenesis, that we get the end product as methane and carbon dioxide. So this happens in anaerobic composting. So the same is explained here, the three steps involved in anaerobic composting. So the first step is enzyme mediated transformation, or it is also called as hydrolysis, enzyme mediated transformation of higher molecular mass compounds into the compounds stable for use as a source of energy and cell tissue. Then the second step is the bacterial conversion of compounds resulting from first step into the lower molecular mass intermediate compounds. And the last one is bacterial conversion of intermediate compounds into simpler end products, that is methane and carbon dioxide. So these are the 3 steps involved in anaerobic composting. Then let us understand what are the design considerations for aerobic composting process and anaerobic composting process. So first we will discuss the important design considerations for aerobic composting process. So the first is the particle size. So irregularity in shape you can reduce by shredding the waste, so before undergoing composting. So the reduced particle size increases the biochemical reaction rate. Why? Because here we get increased surface area. So more surface area after breaking the particles or the materials involved in the solid waste. So more surface area, more biochemical reaction rate. So the particle size influences the bulk density, then internal friction and the flow characteristics and the drag forces of the material. So the desirable particle size, or for optimum results, the size of the solid waste should be 25 to 75 mm. So that is the desirable particle size for composting in aerobic composting process. So the next is the CN ratio, that is carbon nitrogen ratio. So this is the most critical environmental factor for composting. So the living organisms which are present in the solid waste, they utilize 30 part of the carbon to each part of nitrogen. So the initial CN ratio, that is of 30, that is 25 to 50, average is 30, would be most favorable for rapid composting. Then a range of 26 to 31 is consider or desirable limit of CN ratio. Then at lower ratio, the ammonia is given off. Also biological activity is impeded. And at higher ratio, if the ratio CN ratio is higher, the nitrogen may be a limiting nutrient. So if the carbon and nitrogen is not balanced, your reaction will not be proper. So if you want to increase the C, that is carbon, you have to add straws, sawdust, paper, etc., which contain carbon in it. And to increase the N, that is nitrogen, you have to add sludge, slaughter or house waste, etc., which contains more amount of nitrogen. So you have to balance the carbon and nitrogen ratio. So the first is particle size, second is carbon nitrogen ratio, and the third one is blending and seeding. So blending and seeding, the composting time can be reduced by seeding with partially decomposed solid waste to extent of about 1 to 5% of the weight. Means here the proper blending of carbonaceous and the nitrogenous material for a proper CN ratio is very much essential. So the materials which are too wet or the materials which are too dry for good composting can be blended in a proper proportion to achieve the optimum moisture content. So what is mean by seeding? Seeding involves addition of a volume of microbial culture sufficiently large to effect the decomposition of receiving material at a faster rate. So we need, as it is a aerobic composting process, we have to supply oxygen, that is in the presence of oxygen. So blending and seeding helps to maintain the oxygen level also. So the composting time can be reduced by seeding with partially decomposed solid waste to the extent of about 1:5% by weight. So the sewage sludge can also be added to prepare the solid waste. So this includes the blending and seeding. So blending means what? Proper blending of carbonaceous and nitrogenous material to maintain a proper C/N ratio, that is very much essential. And seeding means what? It involves addition of a volume of microbial culture. Okay, you have to add additional volume of microbial culture sufficiently large to effect the decomposition of the receiving material at a faster rate. So you have to add one microbial culture to increase the rate of decomposition. Then the next important factor for designing of the aerobic composting process is the moisture content. So the moisture content should be in the range of 50 to 60% during the composting process. So the optimum value appears to be 55%. So if the moisture content goes below 40%, the rate of composting will be slower down. And if the moisture content is too high, that is more than 77% or more than 70%, then anaerobic conditions would set in. So you have to maintain a proper moisture content, which is very much essential for decomposition of the solid waste. Then the optimum is, or the optimum value appears to be 55%. Then the next is mixing and turning. So to prevent drying, caking and air channeling, the material in the process of being composed, that should be mixed or turned on a regular schedule or as required. So to prevent it from drying, caking and air channeling, you have to turn it on a regular frequency. So the frequency of mixing or turning depends upon the type of composting operation. So here mixing and turning also is required. Then the next is the air requirement. So the theoretical or air should reach all the parts of composting material. The theoretical quantity of oxygen required can be estimated. Okay, there will be certain equations by which you can determine what is the air requirement. So the air with at least 50% of initial oxygen concentration remaining should reach all the parts of composting material for optimum results. So especially in mechanical composting, this plays a very important role. Then the next is the temperature. So temperature, the 50 to 55%, 55 degrees centigrade for the first few days, then 55 to 60 degrees centigrade temperature for the remainder of the active composting period. Then the temperature of 65 degree reduces the biological activity significantly. So for the best results, the temperature should be maintained is between 50 to 55 degrees centigrade for the first few days. Then in between 55 to 60 degrees for the remainder of active composting period. And if the temperature goes beyond 65 degrees centigrade, the biological activity is reduced significantly. So the temperature also plays a very important role. Then the next is the pH control. So this is again a very important parameter in evaluating the microbial environment and the waste stabilization. So the pH value varies with time during composting process. So to achieve an optimum aerobic decomposition, a pH should remain at 7 to 7.5. So for optimum aerobic decomposition, the pH we have to maintain is 7 to 7.5. Then to minimize the loss of nitrogen in the form of ammonia gas, the pH should not rise above 8.5. So if the pH goes above 8.5, so to minimize the loss of nitrogen in the form of ammonia gas. So to minimize the loss of nitrogen in the form of ammonia gas, the pH should not rise more than 8.5. So the initial pH of municipal solid waste will be between 5 to 7. So in the first few days of composting, the pH drops to 5 or less, and at this stage the organic mass is at ambient, that is room temperature. The multiplication of indigenous mesophilic organisms begin and the temperature rises rapidly. So this we have discussed in the phases of decomposition or composting. So in the initial stages the temperature will be less, then the temperature goes on increasing, and at the final stage the temperature again decreases. So mesophilic and thermophilic bacteria play a role. So the product of this are simple organic acids which cause drop in pH. So after 3 days the temperature reaches a thermophilic stage. So here thermophilic means the temperature loving, you can say, and when this stage reaches, the pH rises to approximately 8 or 8.5. So for remaining of the aerobic process, the pH remains 8 to 8.5. Then pH falls during the cooling stage, that is the last stage, and it reaches to 7 to 8 in the mature compost. So in none of the stage the pH has to go below 4.5. In none of the stage, that is starting to the end, the pH should not go below 4.5. Otherwise what will happen? An anaerobic condition will set in, and this may result in the death of the most of the microorganisms which are involved in the decomposition. So composting process will be retarded if the pH goes below 4.5. So pH plays a very important role in the composting process. Then the next is the control of pathogens. So control of pathogens means 60 to 70 degrees centigrade for 24 hours kills all the pathogens, weeds and seeds which are present in the solid waste. So the destruction of pathogenic organisms is an important design element. So why? Because it will affect the temperature profile and aeration process. So if properly conducted, it is possible to kill all the pathogens weeds and seeds during the composting process. So to do this, the temperature must be maintained is 60 to 70 degrees centigrade for 24 hours. If you maintain, it will kill all the pathogens, weeds and seeds which are present in the solid waste, municipal solid waste. Then next is the degree of decomposition. So this can be measured by measuring the final drop in temperature, then the degree of self-heating capacity, then amount of decomposable and resistant organic matter in the composted material, then rise in redox potential, oxygen uptake, growth of the fungus, that is Chitinum gracilis, and the starch iodine test. So these are the different ways by which you can measure the degree of decomposition, or you can estimate the degree of decomposition by measuring the final drop in the temperature, or by degree of self-heating capacity, or by amount of decomposable and resistant organic matter in the composted material, then rise in the redox potential, then oxygen uptake, growth of fungus, then and starch iodine test. So a low COD values, that is the low COD value and a high lignin content, that is more than 30%, is indicative of stable compost. So these are the different ways by which you can measure the degree of decomposition. Then the one more parameter is land requirement. So if you want to put up a plant for composting, so it should have a capacity of 50 tons per day. Then the area required is 6,000 to 8,000 meter square area is required. So the land requirement for a plant with the capacity of 50 tons per day. So if you want to sell 50 tons per day, you want to generate the compost, then you will have to set up 6,000 to 8,000 meter square area you need for the setup. So the land area required for a large plant will be less on a ton per day basis. So that all depends upon how much capacity of the plant you want. So these are the important design criteria for aerobic decomposition.